Okay, my neighbor stopped drilling. Let's try to finish. We have 2 more questions to go. So let this, let's see this question. We have a polynomial of degree 4. The leading coefficient is 4. Oh, I'm not using this pen. Actually, I'm using my. Okay, we have a polynomial of degree 4. And we want to find all zeros of this. Zeros, remember, is x-intercepts. Sorry, I don't know what's going on with my throat. Okay, zeros means solution. So when this equation is said to be 0, or the x-intercepts. So given x plus 1 is a factor. So you could use long division or short division. So for me, I like to use short division. So what I do with short division is I only deal with the coefficient. So the leading coefficient is 1. So I write down here. The next one is -5. Let me type it. So I have -5. Then next one is 4. Next one is 6. And the constant term is -4. So I don't have to write down the variables. And then with x plus 1, I write a -1 outside. Then what do? First, I write this 1 down under this line. Then use this 1 to multiply -1. I get -1. Then I put under -5. Then I add those 2 numbers. Add -5 with -1, get -6. Then I multiply -6 with -1. I get a positive 6. I add those 2 numbers. I get 10. Then I use 10 to multiply -1. I get -10. -10 plus 6, I get -4. Then I use -4 to multiply by -1. I get a positive 4. I add a -1 and 4, I get 0. Okay, when we reach 0 in the end, that means -1 is a 0. So -1, oh, somehow the solution already show. I already clicked the solution. So you see -1 is 1, 0. So then with this, we can keep going. Let me change my color. Do I get to change my color? Not really, I don't see different colors over here. Let me change it to a red color. So then I work with this one, right? So now I know it's 2, but you can always try the factors of -4, which is +-1, +-2, right? And +-4. So I try 2, since I know already, let's save time. So, because -1, I get a -1 is 0. Then 2, I just put 2 here. So I put this 1 down. Also multiply this 1 with 2, I get 2. 2 plus -6, that's -4. I multiply -4 with 2, I get -8. I put it under 10. I add those 2 numbers, I get a positive 2. 2 times 2, that's positive 4. -4 plus 4, that's 0. So 2 is a 0 for the polynomial 2. Now what's left? I left with 1x squared minus 4x plus 2. And this is not factorable, right? It doesn't have a rational factors anymore. So what do? We'll perform quadratic formula. Quadratic formula is in negative. B is -4, so negative become +4. Plus minus square root of b squared minus 4ac. Well, -4 squared is 16. Minus 4 times a is 1. Times c is 2. So I have 16 minus 8, basically. 16 minus 8, which is 8. So I have a square root of 8 here. Then all divided by 2, 8 is 1, right? The number before x squared is called 8. This is divided by 2. So negative 4 divided by 2, positive 4. Sorry, I make mistakes those days. My brain is just not function very well. So 4 divided by 2, that's just 2, plus minus square root of a. Square root of a is 2 radical 2. Then 2 divided by 2, we just left with square root 2. Right, so use a quadratic formula. So I have 4 solutions, or we have 4 zeros. Negative 1, 2, 2 plus square root 2, 2 minus square root 2. Okay, that's number 8. Now let's erase all this. Let's go to number 9. Number 9, we want to find the inverse function of this given function. So f raised by negative 1, that means the inverse function of this. Inverse function, which means we need to solve for x. In this case, we want to isolate x. So let's call this f of x, y. This is easy writing. If we keep writing f of x, that's very tedious. So we have 1x, just x, right? X plus 2. So on both sides, we multiply by x minus 4. So let's write the left-hand side first. So y multiply x minus 4 equals to x plus 2, right? So I multiply both sides by x minus 4. So y times x minus 4 equals x plus 2. Now let's simplify this. So xy minus 4y equals to x plus 2. I want to solve for x, so I need to put the x term together. So I do xy minus x. I'm moving positive x from the right-hand side to the left. Equals to 2 plus 4y. Right? So moving negative 4y from the left-hand side to the right-hand side become positive. Now, on the left-hand side, I can factor out x. So y minus 1 equals to 2 plus 4y. Now I'm dividing y minus 1 on both sides. So x equals to 2 plus 4y divided by y minus 1. So that's my inverse function. So then I change my notation. I change x to be f raised by negative 1. I change x to be f raised by negative 1 of x. Then I change the y in the equation to be x. So the 2 plus 4y in the numerator. And in the denominator, I have y and minus, x. Change y to be x. So 2 plus 4x and x minus 1. Because we want to represent it as a function of f inverse of x. So in terms of x, just by convention, all right? If you have to argue what's wrong, I keep y, nothing's wrong, just by convention. So let's click the solution. You see the f inverse of x equal to 2 plus 4x divided by x minus 1. Okay, that's 9. Now let's do 10. Let me erase this. So 10, a bacterial culture starts with 340 bacteria and grows at an exponential rate. So we know that's exponential function, right? So when we deal with the live applications, we're looking for keywords. So exponential rate tells us that's an exponential function. After 2 hours, there will be 680 bacteria. So with exponential function, so the A is express the population P after T hours as a function of T. Let's just see this. 340 e to the, okay, I will explain where does this come from. So let's write on top. So we're working with this P of P equals to remember we use P naught, I think, e to the kt, right? That's the equation we're working with. P naught means initial value. So in this case, you see initial value is 340. So at the beginning, we have the 340 bacteria. Oh my goodness, I thought it was stopped. Let's start it again. So then after 2 hours, there will be 680. So where do we get this? So 680 equals to 340 times E raised by 2 hours. So T is 2K. Then we can solve for K. We need to solve for K. So how do we solve for K? We take a log on both sides. So we take a log on this side, we take a logs on this side. And then we see this 340. So this simplifies to be ln 340 plus 2K times ln E. ln E equals 1, right? Remember, this is the property of log functions. If I have product, that splits into 2 logs. And this exponents of E come in front of the log. So that's why I have 2K ln E. But ln E is just 1. So we have this one equals to ln 340 plus 2K. Then we can solve for K. So we move ln 340 to the other side. 2K equals to ln 680 minus ln 340. Now, when we have subtraction of 2 logs, we can combine those two into 1 log with a quotient. So 2K equals to ln 680 divided by 340. Well, what's ln? So that's ln 680 divided by 340, that's 2. So we have ln 2. So then K equals to ln 2 divided by 2. What's that half? Or you can think as a half of ln 2. Well, ln 2 is a number, it's an irrational number, right? So then we put back into our equation. So our equation is this. You see in this, they evaluated K to be half ln 2 to be 0.3465 T. You don't really have to do that. So after 5 hours, we just plug in 5 for T. Oh, such noise. So now I would like to write the equation like this. 340 e to the power. So I'm going to put a parenthesis to indicate that that's all powers. Sometimes we read as this exp, but let's do this for this class. So K is ln 2 divided by 2, then multiply by T. All right. So I don't like to use calculator to approximate, because ln 2 gives me the exact value. So after 5 hours, I just substitute T into 5. So let me do the calculation on the side. So that's 340 times e to the power ln 2 divided by 2, then multiply by 5. Then you can use calculator, okay, because we have rounded it to time t. But we have rounded the population, because this is a lab application. Okay, so this makes sense actually, the decimals. So that's the answer. The answer is 1923. It's rounded. Okay, the population is rounded to the integers. How long will it take for the population to reach 2,6? So we have to form another equation. So the equation for this is 2,690 equals to 340 times E raised by ln2 divided by 2 times t. We need to find the time t. So first we can divide the 340 on both sides. Then we'll have e to the ln half t. Well, remember e to the ln something just equals to the value of it. So half we can move to be the exponent of 2. That's square root of 2. So let me finish this. So first we divided by 340. Right, you can use a calculator for this. Then this side becomes, let me type 2,690. So 0 cancel out. Let's see, 269 divided by 34 equals to e to the power ln. So e to the power ln square root of 2, because half goes to be the exponent of 2. So ln square root of 2. How do I write that? But the e to the power, that's another property. E to the ln of certain value equals certain value. So this basically is equals to square root of 2 times t. Then we divide by square root of 2 on both sides. So get a t. So if you use a calculator, t is about 6 hours. So we need to round it this number. 5.96, so we rounded it to 6 hours. All right, I'm going to stop right here. My neighbors is makes a lot of noise.